Hi, this problem is about force between charges under electrostatics. So here the problem says that there are four charges, two capital Q and two small q placed on four corners of a square, and net system is such that there is no resultant force on smaller q in the system. So what we'll do is we'll identify multiple forces working on small q because of the other three charges, and then we'll balance out these forces. So as you would notice, we are presuming all the charges to be positive. So from two capital Q's we have two forces operating on this smaller q charge, which is F1 and F2, and then we have a F3 force coming from the other end of the square, the diagonal one on a small q. Now we know that the diagonal in a square is at 45 degree, so the forces will also make same angle. That's a parallel lines property. Now as they say that there is no net force on smaller q, that means all the charges should balance out in both the x and y axis. So here we are evaluating charges in x axis, and we have F1 and we have cos component of F3, which is F1 plus F3 is equal to 0. That means F1 is equal to minus F3 x component, which is minus F3 cos 45. Similarly, on the vertical side, which is on the y axis, we have F2 and we have F3 sin 45, and we are saying net forces here. So that means F2 plus F3 sin 45 has to be 0. That means F2 is equal to minus F3 sin 45. Now we will put values for these forces. So F1 is 1 by 4 pi epsilon 0. We can also write it as capital K. So that is KQ small q divided by A square is equal to minus of K smaller q square to A square, because there is a distance. The length of a diagonal in a square is A root 2. And we have the formula F is equal to 1 by 4 pi epsilon 0 or K Q1 Q2 over R square. R is the distance. So from this equation we have stricken out K, it's on both the sides in one small q. So we are left with Q small q is equal to minus 2 root 2 q. Now we'll verify this in the other equation. Here also we'll put the values similarly, and what we arrive at is that we were right. Smaller q is equal to minus 2 root 2 q. Now you will find many such problems in this chapter of this type, and that is how we are supposed to address that. So first work out all the forces acting on the point charge, and then balance out those forces, and you will arrive at your required outcome. So a very interesting first chapter of NCERT grade 12th, and has some very good concepts in this. Thank you.